Alright, let's go ahead and work on test 5. And if I'm going to read the first problem, it says use the product rule to multiply radical 3x times radical 2x. So the easiest way to work this out is to combine the radicals because there's nothing I can simplify. So radical 3x times radical 2x. I can't find the square root of 2, perfect square root. I can't find the square root of 3, so I'm going to combine the radicals. 3x times 2. 3 times 2 is 6 radical x. Final answer. Use the quotient rule to simplify. So let's go ahead and see what we have here first. I have radical 21 over 100. And I can't find the perfect square root of 21, so I'm going to go ahead and find the square root of 100. So square root of 21 over square root of 100 is 10. So that is your final answer. Radical 21 over 10. Use the quotient rule to simplify. There's so many ways of working with a problem like this. What I would like to do is first I would write down the problem here. So square root of 2x squared over 49y8. Right? And I'm going to see if I can find the square root of each of them separately. Can I find the square root of 2? No. So 2 stays. Right? So I'm going to write it down like this. So square root of 2. I can't find, so it stays. Let me finish the numbers. Square root of 49. Yes, I can find the square root of 49, and that would be 7. So 49 comes outside and becomes a 7 because square root of 49 is 7. Now going back to x squared. Remember what square root of x squared is? X. Square root of y power 8. So how am I finding the square root of y power 8? So square root of y power 8. If I rewrite this, then that would be y power 8 to the power half. I'm writing it in exponential form, and that would be y 8 times half, which is 4. So technically, every time you're finding the square root of a variable with the power, you're simply dividing with the 2. Like in this case, 2 divided by 2, 1. 8 divided by 2, 4. Right? So here I would simply have square root of 2, because I cannot find the square root of 2. X is outside the radical, because 2 over 2 is 1. Square root of 49 is 7. Y power 8, radical square root of y power 8 is simply y power 8. The power 8 divided by 2, which gives me to the power 4. Use the quotient rule to divide. So here, what I would do is I see cube roots separately. So what I'm going to do here is I'm going to combine the cube roots. I'm going to put them under one cube root. So 250 a power 7 over 2a. Now I'm going to go ahead and see if I can simplify this one. 2 goes into 250 125 times. So that's going to be 3. That's the 3 from outside. And this 3 is the index. And 250 over 2, 125. A and a power 7 give me a power 6. Now I'm going to go ahead and see if I can find the cube root of 125. Cube root of 125 is 5. So this 125 comes outside as 5. So this one would come outside as 5. So times 5. Cube root of a power 6. Remember, how do we find the cube root or square roots? We're going to simply change them to exponential. So cube root of a power 6, when I change it to exponential, it simply becomes a power 6 over 3. And that's going to be a squared. When I go ahead and find this, 3 times 5 is 15. A squared is the final answer. So when you're working things out, the best way to work is numbers, numbers, variables, variables. So in this case, first I combine the radical. And then I simplify 250 over 2, which gives me 125. A power 7 over a, which gives me a power 6. And then find the cube root of 125, which is 5. Cube root of a power 6, which is 6 divided by 3, a squared, and combine everything. When you're working with these problems, just make sure you're a little bit more patient and more careful, because usually what students do is they end up adding 3 and 5 and give a 8, or just leave it 3 and 5 and make it a 35. The operation between 3 and 5 is multiplication, so you have to multiply. All right? Subtract the following radicals. Students kind of get confused, panic when they see radicals. But when you treat radicals as variables, then it becomes so much easier. Now I see that one is radical 75, the other is radical 28, the other is radical 27. So it's like all different variables, x, y, and z. I can combine them. So what do? My next step is to stop and think. So now I'm thinking, when I see 75, it's a square root. I'm going to rewrite this. I'm going to rewrite this as 10. 75 could be 25 times 3 minus 2. 28. 28 is 7 times 4. So now you might be asking me why I'm picking only these numbers. Remember, whenever I try to simplify a square root, I try to pick a number which is a perfect square. 75 could be anything times anything, but I'm picking only 25 times 3 because 25 is a perfect square. 28 could be 2 times 14, but I only pick 7 times 4 because 4 is a perfect square. I always want to make sure there's a perfect square inside it. Minus 2, 27 is 9 times 3. See, 9 is a perfect square. That's the way to simplify. Now, I know that square root of 25 is 5, so 25 comes outside as 5. 4 comes out of the radical as 2. 9 comes out of the radical as 3. So it's 10, 25 coming out of the radical, times 5. Radical 3 minus 4 coming out of the radical, 2 times 2 minus 2. 9 comes out of the radical as 3 times 3, radical 3. So this 25 comes out as 5, this 4 comes out as 2, this 9 comes out as 3. Now 10 times 5 is 50, radical 3, minus 4, radical 7, minus 6, radical 3. Now I'm going to go ahead and think if I can combine anything. Hey, I have radical 3, radical 3. I can put them together. So 50 minus 6 radical 3 gives me 44 radical 3. And I cannot do anything with radical 7, so I leave it that way. Final answer. 7 radical x minus 7 times 6 radical x minus 4. There's so many ways of doing it. If you see in my previous video, I showed you doing arrows, but now I'm going to show you using a box. It's a simple, easy way. So I'm going to write down 7 radical x and negative 7. So this is 7 and this 7 is written down here, right? And a line. And I'm going to write down my 6 radical x minus 4 here. Actually, I'm going to write it one step below so it's easy for us to see. So this is going to be 7 radical x, and this is going to be... Okay, I'm writing it down as a box so it's easy for me to multiply. So 7 times 6, 42. Radical x times radical x is radical x squared. Right? 7 times negative 4 is negative 28 radical x. You see what's happening? I'm multiplying each of this with this one. Now negative 7 times 6 is negative 42 radical x. Negative 7 times negative 4 is positive 28. Now I see that I can combine these two. So when I go ahead and combine it, negative 42, negative 28 gives me negative 70 radical x. 42 square root of x squared is 42x. 28, I bring down the 28. That's one way of doing it. Or, if you want to go ahead and do it the regular way, 7 radical x minus 7 times 6 radical x minus 4. 7 times 6, 42 radical x squared. 7 times negative 4, 7 radical x times negative 4, negative 28 radical x. Negative 7 times 6, negative 42 radical x. Negative 7 times negative 28, negative 4, positive 28. When I combine, I get 42x minus 70 radical x plus 28. Either ways, anyways. So when you write it down as a table, then I know that I will not make a mistake, but this might be confusing to some of you, so you can go ahead and do it the traditional way. It's math. We can do it as many ways as possible. Rationalize the denominator and simplify. They ask us to rationalize the denominator. That means the denominator has to be radical free. So I have 2 radical 3 over radical 7. To make sure the denominator is radical free, I multiply it with another radical 7. When I multiply with radical 7 in the denominator, I have to multiply with radical 7 in the numerator. Now let's go ahead and see what happens. 2 radical 3 times radical 7 is radical 21. Radical 7 times radical 7 is radical 49. 2 radical 21. Radical or square root of 49 is 7. Bingo, my denominator is radical free. Sometimes there will be a case where they ask you to rationalize the numerator, and you got to make sure and see you're doing it the right way. Rationalize the denominator again, but in this case it's not a radical, it has a constant term too. So you multiply with the conjugate. So conjugate of negative 5 radical 10 is 5 plus radical 10. So I'm going to multiply with the conjugate. 5 minus radical 10 times 5 plus radical 10. 5 plus radical 10 on the numerator. So now let's go ahead and work with the numerator. 5 times 2, 10. 2 times radical 10 is 2 radical 10. It's like multiplying 2 times x, which is 2x. Now the denominator. When you multiply conjugates, you can go ahead and FOIL it out, but the simple and easy way to multiply conjugates is simply the first term times the first term. 5 times 5, 25. Second and second. Negative radical 10 times negative radical 10, it's the negative radical 10 times radical 10 is negative radical 100, which is negative 10, because square root of 100 is 10. So what do I get? I get 10 plus 2 radical 10 over 15. So every time you multiply the conjugates, you don't have to FOIL it out. Let me show it to you why. 5 minus radical 10 times 5 plus radical 10. Even if you FOIL, you will still end up with the same answer. So let me just do it the square way I was talking about. 5 minus radical 10, 5 plus radical 10. So I write one parenthesis here and one parenthesis here. 5 times 5, 25. 5 times radical 10, 5 radical 10. Negative 10 times 5, negative 5 radical 10. Negative radical 10 times negative radical 10 is negative radical 100, that is negative 10. You see that I have positive 5 radical, negative 5 radical cancel out, 25 minus 10, 15. So even if you FOIL, you will still get the same answer. But whenever you have conjugates, to save time, you simply multiply the first times first and the last times last. All right? Solve the radical equation. Square root of 4x minus 3 is equal to 5. To solve the radical equation, first I'm going to square on both sides so it can be radical free. So now I have 4x minus 3 on this side and 25, because when you square a radical, you get rid of it. Add 3 on both sides. I get 4x is equal to 28. Divide by 4. X is equal to 7. Your final answer. Now let's go ahead and look at the next one. Solve the equation square root of 5x minus 4 minus 2 is equal to 2. Whenever you're solving radicals, the first step is to make sure the radical is by itself. So this is my radical. That is not by itself. I have an extra 2. What do? I move it to the other side. So if I rewrite it, I have radical 5x minus 4 minus 2 is equal to 2. I don't need the 2 here, so I add 2. What do I get? Radical 5x minus 4 is equal to 4. Now, is the radical by itself? Yes. I don't have anything around the radical. Everything is inside the radical. So the first step to make sure is to have your radical by itself. Once that is the condition, the next step is to make it radical free or eliminate the radical. So how do I get rid of the radical? Simply by squaring. You cannot square it here because the radical is not by itself. So you have to make sure the radical is by itself and then square it. Now squaring gets rid of the radical, and 4 squared gives me 16. Same procedure, add 4 on both sides. I get 5x is equal to 20. Divide by 4. I get x is equal to 5. Oops. Divide by 5. Divide by 5 on both sides. I get x is equal to 4. I had the answer in my mind. Problem 11. Solve the radical equation. In this case, I'm going to look at the radical first. Is the radical by itself? Yes, because everything is inside the radical. I don't have anything beside it. So what do? I square both sides. Squaring the radical makes it get rid of the radical. Now what do I have here? X plus 1 squared. So that is x plus 1 times x plus 1. I'm going to go ahead and FOIL it. X times x, x squared, x times 1, x. Now the next one, 1 times x, x, 1 times 1, 1. So this gives me x squared plus 2x plus 1. And 11 minus x on the other side. Remember, I have to make sure everything is to one side. So what do? I subtract 11 and I add x. 11 x cancels, so I have 0 on this side. X squared, 2x plus x gives me 3x. 1 plus negative 11 makes it negative 10. Now once I have it, when you look at it, it is a quadratic equation. So what do? You could go ahead and factor it. Factors of negative 10 that add up to 3 are 5 and 2. Positive 5 plus negative 2 is 3. 5 times negative 2 is 10. Once I have that, I'm going to use principle of zeros, and I'm going to equate each parenthesis to 0. X plus 5 is 0, and x minus 2 is 0. What do I get? X is equal to negative 5, and x is equal to positive 2. Now, which one of these is your answer? You got to go ahead, plug it in into the equation, into this equation, and check. Now, let me start with negative 5. If I plug x as negative 5, I get radical 11 minus of minus 5 is equal to negative 5 plus 1. Negative of negative makes it a positive. So this becomes 11 plus 5 is 16. Negative 5 plus 1 is negative 4. Square root 4 cannot be equal to negative 4. So negative 5 is not my option. I'm going to go ahead and plug it in here. What do I get? Square root of 11 minus 2 is equal to 2 plus 1. Square root of 11 minus 2 is 9. Square root of 9 is 3, and 3 is equal to 3. Alright, you always have to check which one is your answer. Find the length of the unknown side of the triangle. So I'm going to take the unknown side as x. As you see, this is a right angle triangle. So the square of both sides is equal to square of the other side. So it's a squared plus b squared is equal to c squared. Now my a here, I'm going to take this as a, take this as b, take this as c. My a here is 6 squared plus 2 squared is equal to x squared. 6 squared is 36, 2 squared is 4 is equal to x squared. So I get 40 is equal to x squared. I am not looking for x squared, I'm looking for x. So I find square root on both sides. So I get x is equal to square root of 40. I can go ahead and simplify 40 to 4 times 10. So you might ask me why only 4 times 10, because 4 is a perfect square and 4 gets kicked outside as 2 radical 10 is your final answer. Simplify using I notation as needed. So when I rewrite it, it is negative 54. As we know, I squared is negative 1. I'm going to replace my negative 1 with I squared 54. Right? I mean, students don't have to do this. If once you see a negative, you know your final answer is going to be I. So, but it's nice to go ahead and break it down. So 54, I can rewrite 54 as 9 times 6. I always pick a perfect square. So what happens? Square root of I squared is I. Square root of 9 is 3. And radical 6 stays inside. 14, add 2 minus 8i, 9 plus 5i. When I add them, 2 plus 9, 11. Negative 8 plus 5i is negative 3i. Final answer. Multiply and write as a plus bi form. When I multiply, let me rewrite it so you can see. 5i minus 3. 5i times 3, 15i. 5i times negative 4i is negative 20i squared. Remember, the highest power of I has to be I. So if I see a I squared or higher, I have to change it. So I squared is negative 1. I'm going to go back and put that in here. 15i minus 20 times negative 1. That becomes 15i plus 20. I got to rewrite it in a plus bi form. So it's going to be 20 plus 15i. Final answer. So rewrite this one again. 2i, 5 minus 8i. 2i times 5 is 10i. 2i times negative 8i is negative 16i squared. Remember, I can't have I squared. I squared is negative 1, so I'm going to replace it here. So 10i minus 16 times negative 1. That becomes 10i plus 16. I'm going to rewrite it in a plus bi form. It becomes 16 plus 10i. Now let's go ahead and do the next problem. 2 minus 5i squared. That is 2 minus 5i times 2 minus 5i. So let me just do the box way. So here I have 2 minus 5i and 2 minus 5i. 2 times 2, 4. 2 times 5, negative 10i. 5i times 2, negative 10i. 5i times 5, negative 5i times negative 5i is positive 25i squared. Remember, I squared is negative 1, so I'm going to replace this with negative 1. That becomes a negative 25. Now I can go ahead and combine these two. So negative 10i gives me negative 20i. And negative 25 plus 4. And that would be negative 21 minus 20i. Now you might go ahead and also multiply or FOIL the regular way, which is the same as well. 2 times 2, 4. 2 times negative 5, negative 10i. Negative 5i times 2, negative 10i. Negative 5 times negative 5 is positive 25i squared. And I squared is negative 1, so it's negative 20i because I combined these two. Plus 25i squared is 25 times negative 1. And when I combine these two, I get negative 21 minus 20i. Either way, whatever way you are comfortable with. Solve the quadratic. Before you go ahead and solve the quadratic, you got to make sure the quadratic is in the standard form. So I'm going to take the 6 to the other side. So I subtract 6x from both sides. So I would end up having x squared minus 6x plus 5 equal to 0. Right? So I have x squared minus. Now, once I have this, I'm going to go back and let me rewrite it here. I'm going to go back and find out my a, my b, and my c. Remember, they're asking us to use quadratic formula. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant. Once I have this, I'm going to plug into the formula minus b plus or minus b squared minus 4ac over 2a. So when I plug in, I have negative of negative 6 plus or minus b squared negative 6 squared minus 4ac. I'm squeezing it in here over 2 times a. So I have negative of negative 6 becomes a positive 6 plus or minus negative 6 squared is 36 minus 4 times 1 times 5 is 20 over 2. 36 minus 20 is 16. 6 plus or minus square root of 16 over 2. Square root of 16 is 4. 6 plus or minus 4 over 2. So I have two cases here. Case A, 6 plus 4 over 2, which is 10 over 2. That is 5. B, 6 minus 4 over 2, which is 2 over 2. That is 1. So your answer, x is equal to 5 and 1. Now let's go ahead and solve number 19 using quadratic formula. It's already in the standard form. A is 1, B is negative 6, and C is 13. Plugging it in, minus B plus or minus b squared minus 4ac over 2a. So negative of negative 6 plus or minus negative 6 squared minus 4 times a times c over 2 times a. Negative of negative 6 becomes a plus 6 plus or minus square root of 36 minus 52 over 2. So here is 6 plus or minus 36 minus 52 is negative 16 over 2. So that's going to be 6 plus or minus, remember square root of negative 16 is 4i over 2. So I have two cases here. Case 1, 6 plus 4i over 2, right? And what would that be? If I simplify it, 2 goes into 6 3 times, 2 goes into 4 2 times. So 3 plus 2i. Case B, 6 minus 4i over 2. That is going to be 3 minus 2i. When I simplify, 2 goes into 6 3 times, 2 goes into 4 2 times. So you have two answers. Solve using quadratic formula. A is 2, B is 7, C is negative 4. Minus B plus or minus b squared minus 4ac over 2a. So that's minus 7 plus or minus 7 squared minus 4 times a times c over 2 times 2. So that is going to be negative 7 plus or minus 49, 7 squared. Negative times negative 4 is 16. 16 times 2 is positive 32 over 4. That's equal to negative 7 plus or minus square root of 81 over 4. So that is equal to negative 7 plus or minus square root of 81 is 9 over 4. Two cases, negative 7 plus 9 over 4, negative 7 minus 9 over 4. Negative 7 plus 9 is going to be 2 over 4, and that's going to be a half. This is going to be negative 7, negative 9, negative 16 over 4 is going to give me negative 4. So you have two cases here, x is equal to half or x is equal to negative 4. Alright, solve using quadratic formula. They ask us to solve using quadratic formula, but it's not in the standard form. So let me FOIL this out. X plus 4 times x plus 2 is equal to 7. X times x, x squared. X times 2, 2x. 4 times x, 4x. 4 times 2, 8 is equal to 7. Now I'm going to combine first. 2x plus 4x, 6x plus 8 is equal to 7. It's not in standard form, so I'm going to subtract 7. So it's going to be equal to 0. 0 is equal to x squared plus 6x plus 1. Now it's in a standard form. So I'm going to solve using quadratic. A is equal to 1, B is equal to 6, C is equal to 1. Minus B plus or minus b squared minus 4ac over 2a. Minus 6 plus or minus 6 squared minus 4 times a times c over 2 times 1. That is negative 6 plus or minus 6 squared is 36 minus 4 over 2. That is negative 6 plus or minus 36 minus 4 is 32 over 2. Now the question is, can I go ahead and simplify 32? Yes, it's negative 6 plus or minus 32 is, okay, 16 times 2. 16 times 2 over 2. So the 16 comes outside as 4. So negative 6 plus or minus 4 radical 2 over 2. So I have two cases here. Case 1 is negative 6 plus 4 radical 2 over 2. And the other is negative 6 minus 4 radical 2 over 2. When I simplify this with 2, 2 goes into 6 3 times, 2 goes into 4 2 times. So negative 3 plus 2 radical 2. Or the other way of working it out is I'm going to factor 2 out from here. So if I factor 2, I get 2, negative 3 minus 2 radical 2 over 2. Cancel out. It's negative 3 minus 2 radical 2. So either ways, I have two answers here. Negative 3 plus 2 radical 2 or negative 3 minus 2 radical 2. Find the vertex of the quadratic function. The vertex of the quadratic function is negative b over 2a, comma, f of negative b over 2a. So let me go ahead and find, this is the x and this is the y. Let me go ahead and find the x first. Negative b over 2a. What is my quadratic equation? X squared plus 2x minus 8. In this quadratic, my a is equal to 1, b is equal to 2, c is equal to negative 8. I don't need c, but I'm just writing it down. So vertex is negative b over 2a, so negative 2 over 2 times 1, which is negative 1. So my x is negative 1, and now I'm supposed to find y, which is f of negative b over 2a. That is f of negative 1. So how do I find f of negative 1? What is my function f of x? F of x is x squared plus 2x minus 8. F of negative 1, remember the negative 1 is the x value. That's what is the formula for vertex. F of negative b over 2a. I got negative b over 2a as negative 1, so I'm going to find f of negative 1. So negative 1 squared plus 2 times negative 1 minus 8. That is 1 minus 2 minus 8. Gives me negative 9. So my vertex here is negative 1, comma, negative 9. Hope this helps.